In this video, I'll demonstrate how Apica can help you collect, process, and route Windows security events generated by Active Directory. We'll begin with the first step, which is ingesting the data into Apica Ascent. For this example, we're using OpenTelemetry to collect and send Windows event data into Ascent. OpenTelemetry provides several options for collecting Windows events, so the exact configuration can be adapted to your environment. Once the collector is configured and the data begins flowing, the new data source automatically appears within Ascent. Here we can see our Active Directory security events coming in. From the log viewer, we can inspect the complete event, including the log message and its associated fields. We can also apply a query to narrow the results and examine specific categories of Windows security activity. However, Windows security events can be extremely verbose. Many environments generate a large number of repetitive or low-value events that do not need to be stored in a SIEM or observability platform. This is where Apica FLOW becomes valuable. FLOW provides a visual representation of the telemetry pipeline. From here, we can see where the Windows security events enter the platform, which processing rules are applied, and where the resulting data is ultimately sent. I already have several rules configured, and I'll walk through what each one does. The first example is a filter rule. For this demonstration, we're focusing on specific Windows security event IDs, rather than building a complete Active Directory filtering strategy. When I open the rule, I can see a live preview showing which events match its conditions. This makes it easier to validate the rule before enabling it and clearly understand which data will be affected. In many environments, it is unnecessary to retain every routine Windows event. For example, Event ID 4634 represents a user logoff. These events can occur at a very high frequency and may provide limited investigative value depending on the organization's requirements. This filter rule identifies those events and drops them as soon as they enter Ascent. I'll go ahead and enable the rule. From this point forward, matching events will no longer be forwarded or stored downstream. Historical events that have already been ingested will remain available, but new matching events will be removed directly within the telemetry pipeline. This reduces unnecessary data volume before it reaches an expensive SIEM or observability platform. Completely dropping an event type is not always the right approach. Sometimes you still want a representative record of an event without retaining every occurrence. In that case, we can apply a sampling or throttling rule. This rule essentially says that when a matching event comes in, only one event within the configured interval should be allowed through. For example, if a repetitive Active Directory event is generated hundreds or thousands of times, FLOW can retain a single representative event rather than storing every duplicate occurrence. This preserves visibility into the activity while significantly reducing the total number of logs sent downstream. Another powerful FLOW capability is the ability to apply custom JavaScript to incoming telemetry. JavaScript rules can be used to modify fields, standardize formats, enrich events, remove unnecessary information, or create new attributes before the data is forwarded. In this example, we're transforming a date field contained in the Windows event. Here we can see the value before the transformation. Once the rule is applied, the field is converted into a cleaner and more consistent format. This can be especially useful when different data sources use inconsistent field names or timestamp formats. Instead of requiring every destination to understand the original format, FLOW normalizes the data while it is moving through the pipeline. Once the data has been filtered, sampled, and transformed, we can send it to the organization's existing SIEM, observability platform, or storage destination. Apica supports a wide range of destinations, including Microsoft Sentinel, Datadog, Azure Blob Storage, and other third-party platforms. For this demonstration, I'm going to send the processed Windows security events to Microsoft Sentinel. To configure that destination, I select the Microsoft Sentinel forwarder and provide the required connection settings. Once enabled, the optimized events will be forwarded directly to Sentinel. It is also worth pointing out that the data does not have to be sent to only one destination. The same telemetry stream can be routed to multiple destinations. For example, An organization could send security-critical events to Sentinel, while also keeping a copy in a lower-cost data lake. You can use your own data lake, or you can retain the data within Apica for later search and analysis. This gives you control over which events are sent to expensive analytics platforms, which events are archived, and which events are removed entirely. Finally, we can visualize the performance of the telemetry pipeline. The pipeline view shows how many events are entering the system, how many events are being processed by each rule, and how many events are ultimately forwarded. Here, we can compare the total volume of Windows security events entering the pipeline with the reduced volume leaving it. This provides a clear measurement of the reduction achieved through filtering, sampling, and transformation. For high-volume data sources such as Active Directory, these rules can significantly reduce the amount of data being sent to a SIEM while preserving the events that are most important for security and operational analysis. With Apica FLOW, organizations gain control over their telemetry before it reaches downstream platforms, helping reduce costs, improve data quality, and ensure that the right data reaches the right destination.